Hi friends, we're going to learn how to do a chi-square lab today, chi-square analysis with your M&Ms. So go ahead and get those M&Ms out and then download the lab sheets that I've got on your assignment for you. And let's take a look at what you need to do. So what is this? We're going to apply this to your fruit fly data later on. I don't know when, at some point, but we're going to apply this technique to your fruit fly data that you're going to get, but we're going to practice using M&Ms because they're easy and it's a great way to learn chi-square analysis, which is one of the last things that we're going to the last thing we're going to talk about in the genetics unit, and then we can begin our review. So we need to cover that this week, and then we are good to go. So if you get your bag of M&Ms out, hopefully you got a big bag, what we're going to do is count how many of each color of M&Ms are in your bag. That's really it. And then we're going to apply those numbers that you all get. We're going to get some class data going, and then we're going to compare those numbers to what is expected. Because when we do your fruit fly analysis, we're going to take a look at the number of F1 and F2 that we got with each trait, and then we're going to compare that to what we would expect to see happen in nature to see if anything's different. So this is a statistical technique we call a chi-square analysis. So we're looking at our results that we get, what we observe, and we're comparing them to what we would expect to get. And that is a chi-square analysis. So you can do a little bit of reading on your lab. I'm also giving you a link to Mr. Anderson on Bozeman Science because he does a great job of explaining this also if you need a little bit more information. If not, just rock and roll. But if you need some more information, I've got a link for that too. So what we're going to do is look at our data here for our M&Ms and create what's called a null hypothesis, a statistical term. And the null hypothesis just means that any difference, you can read it down here at the bottom, between the observed and the expected data is due to chance alone. And we'll talk more about what a null hypothesis is a little bit later. All right, so you're going to need your M&Ms for this next section. When you have your M&Ms, get a piece of white paper. Okay, so you can just pour your M&Ms out on it. And we're going to compare the numbers of green, blue, red, orange, yellow colors, compared that to what the Mars company claims they have as far as distribution goes. So let's say, for example, you got a bag of, like I did, milk chocolate M&Ms. We're going to count all the numbers of brown, blue, orange, green, and red, and you're going to see if that compares to what they actually reported. So if I do this, I'm going to write on this for us here a little bit. Let's say that I'm going to do milk chocolate counts. The Mars company says that 13% of my total should be brown. 24% should be blue, 20% should be orange, 16% should be green, 13% should be red, and 14% should be yellow. Now that's just if I got the milk chocolate, right? If I got the peanut crispy minis, peanut butter or almond, here are my distribution of the colors. All right, so why do we care? We really don't care so much about the M&Ms, but we do care about the distribution because it's going to help us do our analysis. So the first thing you're going to have to do is to count your M&Ms. So if you go to your instructions on your lab, yes, please wash your hands. I'm just capturing this from the pages of your own lab. You'll have to take a look at your own pages. You can either print them off or just use them as a PDF file. It's totally fine. So you're going to open your bags, pour them out. Don't eat any yet. You can eat all of them later if you want to. You're going to separate them into color categories and count the number in each color. Super, super simple, right? So what does this look like? Now, obviously, I did not count all of the M&Ms in my bag because I'm old and tired. So here are the results that I got, though, just from a small sample. I just poured some of them out onto my white piece of paper. I separated them into piles, and I found 18 were yellow, 16 were blue, 14 were brown, 6 were green, 12 were red, and 37 were orange, right? You see a disproportionate number between these? Yes, so it's probably not going to compare exactly. Now you're going to have a much bigger sample size, and we're going to share those data later on in the week. But all you're doing today is just counting M&Ms. Pretty easy. I'm going to show you where to put those numbers once you get them. So once you get your numbers, then you're going to record them in this chart right here. So let's say, for example, I got my numbers here. Find out what I got. I had brown, I had 14. That's my observed number. Blue, I had 18 from my picture there. Orange, I had 37. Green, I had 6. Red, I had 12. And yellow, I had 18. You'll write your total number there. Now, that's all you're going to do today. I'm going to show you tomorrow what to do with all of our data and what the expected are. If you want to look, you would need to apply those percentages to the expected values that we saw in our last slide, right? So let's take a look at that in our last couple of slides here. Boom, boom. There we go. Our expected. So if we compare those numbers total, we figure out our percentages, we're actually going to need our raw data. We're going to have to apply that 13% to our total in order to enter that here. But don't worry about that for today. All right, guys? Just enter your raw data. So if you got 136 brown, 85 blue, and so forth, just put those down, and that's all we need for tomorrow. Okay, so don't get too crazy. If you want to keep reading and find out what we're going to do with that, you're more than welcome to do that. If you want to know what else we're going to do, we're going to be looking at something called the degrees of freedom. The degrees of freedom is 1 less than the total number of choices. So if you count the number of color choices you had, 1, 2, 3, 4, 5, 6 color choices, your degrees of freedom is going to be 5. And I'll explain a little bit more about that tomorrow. If you want to keep reading and look at Mr. Anderson's video, I'll explain that more to you tomorrow. But the degrees of freedom is going to help us apply this chart right here. I had 5 degrees of freedom for the data that I got. And let's say that my number here is, let's say I got a chi-square number when I apply the equation that I'm going to teach you tomorrow. Let's say I got a number that was like, say, I don't know, 11.2. 11.2. So that is a little bit on this side where I would accept the null hypothesis that anything is due to chance alone. Where I know a null hypothesis is that nothing is changing, nothing should change, and they should be, these data are okay. If I'm going to reject my null hypothesis, that means that the difference between what I expected and what I observed was too big. So statistically, there's something going on here. That's what these numbers are telling us here. If I reject my null hypothesis, that means these p-value numbers, and I'll talk to you about that more tomorrow, are too big. And so I'm going to have to go back and say, okay, well, something else is going on. All right, now don't worry about any of this stuff. I'm just trying to give you a brief overview as to what we're actually doing. And this is a page right from your lab. So don't freak out. You have this, no big deal. All right, the only thing you need to do for today, and we'll talk more about chi-square tomorrow, is read over your lab and gather your data that you have for your bag, your one bag of M&Ms, and record it in that section. All right. We're going to look at chi-square more tomorrow. We'll compare our class data. We'll run a chi-square analysis, and I'll walk through that with you. But if you have any blaring questions and you've watched this video before our Zoom conference, then you can bring those up at the conference. Other than that, don't stress. This lab isn't going to be due for a while, but I want you to have that concept in your brain before you seniors take off for next week, right? Because you have that time off that you normally would have been in Jerusalem, which is, I think, after this Friday, Monday, Tuesday, Wednesday of next week. I forget exactly what it is, but I'll let you know. So you seniors, you're not going to be doing anything for a hot second. And then we'll look at this lab after you come back from Easter. I want you to have these data now so you can be taking a look at that. All for today, and I'll see you all tomorrow.